This is a little screencast to show what it looks like to identify contention on the GIL from Rust. So first of all, there's a little application here that is going to, in a given number of threads, run some Python code. We'll just run it quickly. And while we run it, won't take very long, we'll take a look at the code. All it's going to do is, in the number of threads that we've requested, 1,000,000 times each thread, call a Python function, right? Which will acquire the GIL using the CPython create API, and then eval some code that we'll throw away the result from, right? Doesn't need to be that expensive because, as you'll see, actually acquiring the GIL takes a pretty significant amount of time all by itself. So moving back to the other terminal, running with one thread took 8 seconds, right? So if we run with two, what we'll see is that not only will it not be faster, it will take super linear time. Like, it'll take more than twice the amount of time because you're introducing contention on the GIL. And so I think it's going to take 20 something seconds here. When it's done, what we're going to do is run with a much larger number of threads, which will take a much longer amount of time, and then go ahead and, well, it takes longer with QuickTime running, apparently. Wait slightly longer for this to finish. Then we'll run it with a larger number of threads, and you know what? Let's not even wait. As you can see, it takes a lot longer with 2 threads. So let's run it with 16, just so that we're really sure it's not going to finish anytime soon. Then, while it's busily grinding away on the GIL, what we're going to do is switch to instruments. Instruments is OS X or macOS. A tool that comes with Xcode. I think that you actually need to install like the Xcode GUI itself rather than just the Xcode CLI tools. Anyway, it comes with Xcode. It's hidden in Xcode's application directories, but if you looked up instruments and how to install it, you can see this. We are going to go and find what's eating our CPU, which will be this process. So it's 79875. So we go to this all processes dropdown, we select it, and then there's a record button. We're going to option click it because there's something very important that we have to do first. So option click brings up this menu. If we clicked it without option, we wouldn't get this menu, but this menu allows us to select record waiting threads. And this is important because in general, time spent waiting for locks is not shown in a profiler. And so if you don't click this box, you will not see the time spent waiting for the GIL. It'll just be hidden. And the reason for that is that time spent waiting for locks can be things like accessing files or sleeping, you know, and you don't want thread.sleep to show up in your profile necessarily. In this case, we do because we're looking for lock contention. So we'll record. Because there's not a whole lot going on here, we don't have to wait very long. And if my machine weren't overloaded, it would already be rendering some information. But we've gotten a few seconds here. And as soon as I am sure we've gotten a few seconds, we can stop it. Okay, stop. We can also kill the program, which will not have finished after 2 minutes. Okay. We'll wait for instruments to catch up. And yeah, QuickTime uses a lot of CPU apparently. There we go. Okay. So what we see is all of our threads, one top-level entry per thread. I asked for 16, so this is probably 16. There's also a main thread that they were spawned out of. Again, so what you can do is expand these a little bit, and what you'll find is, oh, this is a rabbit hole. I can keep expanding these. So rather than doing that, you can, again, option click on the arrow, and option click will expand all the way down until a particular entry uses less than a majority of the CPU time. I'll just do it and you can see what I mean. Okay, so it expanded all the way down deep. And it expanded down to the point where we have a conditional wait, et cetera, get time of day. And these are taking 3.4% of CPU time. But the more important thing here is if we back up a little bit in the thread stack, what we see is, close up. What we see here is next to one another, these neighbors, acquire GIL and run. Those correspond to the functions that we were actually running in our code, right? We're acquiring the GIL here, and then we're running some Python code here. Because these are discrete steps, it really shows us how long each of these steps are taking. And this thread, no, we're only looking at one thread here, spent 1 second, at least 1 second, acquiring the GIL, and only 180 milliseconds actually running Python code, right? So you can see that the more threads you add, the more time you're going to spend doing that. Yeah, so there's a lot of other stuff that you can sort of do here. You can focus on callers of acquire GIL, and what that'll do is show you only the calls to acquire GIL in all the threads, right? So if you then go and expand those threads, you'll see that all of them were waiting on acquire GIL, right? So that is that. That's how to sort of locate the GIL, locate contention on the GIL via OS X instruments.